Potential energy. Yesterday we learned about kinetic energy. Today we learn potential energy. The potential energy is defined only for conservative force. Potential energy is defined only for conservative force. In the space occupied by conservative force, every point is associated with certain energy, which is called energy of position or potential energy. Potential energy generally are of three types: elastic potential energy, second electrical potential energy, and third gravitational potential energy. Here we learn about gravitational potential energy. First, take change in potential energy. The change in potential energy between any 2 points is defined in the term of the work done by associated conservative force. It displacing the particle between these 2 points without any change in the kinetic energy. That means R1 to R2, these two positions F dot dr. So U2 minus U1 equal to minus integration R1 to R2, F dot dr equal to minus W. And also in a electric field, change in the potential energy U2 minus U1 equal to minus integration E dot dr. E dot dr U1, sorry, R1, R2 into Q minus Q integration E dot dr. This is the potential energy in electric field. This is the potential energy in gravitational field. We can define a unique value of potential energy only by assigning some arbitrary value to a fixed point called the reference point. So here we take a reference point infinite. Same for all point. Infinite is same for all planet, all point. Infinite distance is same. Okay. Whenever where is possible, we take the reference point at infinite. Assume potential energy to be zero. Here is that if R1 is equal to infinite, R2 equal to R, then equation we write minus integration infinity to R, F dot dr is equal to minus W. This is the formula for infinity. Okay. In a case of conservative force, the potential energy is equal to negative of work done in shifting the body from reference position to given position. तो नेगेटिव वैल्यू आती है वर्क की. Next, this is why in shifting a particle in a conservative field, say gravitational electric, if the particle move opposite to the field, work done by the field will be negative. And so change in the potential energy will be positive. Is that potential energy will increase when the particle move in the direction of the field. Work will be positive and change in the potential energy will be negative. Is that the potential energy will decrease. यह हमें याद रखना है. Now in form of a gradient, for only conservative field, F equal the negative gradient of the potential energy. Negative gradient. Gradient means change with position या distance is called gradient. So here del we take d by dx I cap, d by dy j cap, d by dz k cap. So we write f equal to minus du by dx I cap plus du by dy j cap, du by dz k cap. Means we write f is equal to minus du by dr vector. So r is x, y, and z. So also we write f is equal to minus du by dx I cap, du by dy j cap, du by dz k cap. So potential energy change with respect to position vector. It give a conservative force. ये हमें याद रखना है. This is the condition for the conservative field also. And we take in electric field F equal to minus dV by dx. Yeah, R, dr. So V is the potential, R is the position vector. So this is the potential gradient. This is the also condition for the conservative field. Okay, तो हमें याद रखना है. तो du by dx partial derivative of u with respect to x where y and z constant. Du by dy partial derivative of u with respect to y where x and z is constant. And du by dz is equal to partial derivative of u with respect to z where x and y constant. Potential energy curve, U versus X graph. So graph plots between the potential energy of a particle and the displacement. The center of force is called potential energy curve. Okay, this is the potential energy curve. Figure show a graph of potential function U of x for one-dimensional motion. That negative gradient of the potential energy gives the force. याद रखना है. अब फोर्स पॉजिटिव होगा, नेगेटिव होगा और जीरो भी होगा. तो ग्राफ में से कैसे ले सकते हो देखते हैं. Nature of force. First, attractive force. On increasing x, you increase means du by dx positive. Then f is negative. Du by dx positive means d minus du by dx is equal to f. Then f negative. Then f is negative in the direction. Is that the force is attractive in nature. In graph, this is represented in a region BC. So here we take region BC. This region BC. This is the slope is positive. Slope give a du by dx. So slope positive. So du by dx positive. But f equal to minus du by dx. F is negative. Repulsive force. On increasing x, if you decrease here, increasing x in this and you decreasing, so AB also. Okay, so here du by dx negative, slope is negative here. Here slope is negative. Okay, so F is positive, dx is the force is repulsive. In this graph represent the region AB. Then F is positive in a dx. Is that force is repulsive in nature. In the graph, this represented in a region AB. Third, zero force. On increasing x, U does not change. Means du by dx 0. So point C, point D. So F is 0 is the no force work on the particle. Point B, C, D represent the point of zero force. तो B में slope 0, C पर force slope 0, D पर slope 0 means du by dx 0 means F is equal to 0. this point can be termed as a position of equilibrium. तो B, C, D 3 point है वो position of equilibrium indicate करते हैं. तो here we take 3 type equilibrium. ये हमें याद रखना है. 3 type equilibrium. If net force acting on a particle is 0, it is said to be in equilibrium. The equilibrium du by dx is equal to 0, but the equilibrium of particle can be of 3 types. Stable part equilibrium, unstable equilibrium, and neutral equilibrium. So when a particle is displaced slightly from a position, then a force acting on it is bring it back to the initial position. It is said to be in stable equilibrium. Example यहाँ पर दिया गया है. V take. Suppose this particle slightly displaced in this direction. After back to this initial position. Okay, means this is the stable equilibrium. यहाँ पर हम slightly displace करते हैं तो doesn't back to initial position this particle because this is the unstable. वो यहाँ पर ही आएगा तो this is unstable equilibrium. और यहाँ पर slightly हम displace करते हैं तो motion करने लगेगा. This is the neutral. Okay, तो 3 टाइप का इक्विलिब्रियम है. तो unstable, when a particle is displaced slightly from a position, then a force acting on it tries to displace the particle further away from the equilibrium position. It is said to be unstable equilibrium. यहाँ पर bring it back to the initial position. Force acting on it bring it back to the initial position. और यहाँ पर when a particle is slightly displaced from the position, then it does not experience any force acting on it and continue to be in equilibrium in the displaced position. It is said to be neutral equilibrium. Stable equilibrium potential energy is minimum, unstable equilibrium potential energy maximum, and neutral potential energy is constant. So here F equal to all cases du by dx 0, F 0. Okay. Here second differentiation is positive, greater than 0. Second differentiation of potential is negative, less than 0. And second differentiation is 0. तो एक कंडीशन है, कंडीशन हमें याद रखनी है. ओके, डी स्क्वेयर यू बाई डी एक्स स्क्वेयर ग्रेटर देन 0, डी स्क्वेयर यू बाई डी एक्स स्क्वेयर लेस देन 0, डी स्क्वेयर यू बाई डी एक्स स्क्वेयर 0. This is the indication of stable, unstable, or neutral. That means instead the second difference, the rate of change of du by dx is positive. The rate of change of du by dx is negative. The rate of change of du by dx is 0. तो ये एग्जाम्पल हमने लिए थे. ये स्टेबल इक्विलिब्रियम है, अनस्टेबल इक्विलिब्रियम और ये न्यूट्रल इक्विलिब्रियम. ओके, नाउ वी टेक एग्जाम्पल. A particle which is constrained to move along the x-axis is subjected to a force in the same direction, which vary with distance x of the particle from the origin as f of x equal to minus kx plus ax cube. Here k and a are positive constant, or x greater than or equal to 0. The function from of the potential energy U of x of the particle. तो पोटेंशियल एनर्जी चाहिए, ओके, वर्सेस एक्स का ग्राफ. तो दिस इज द कंजर्वेटिव फोर्स. Now here relation between F and U, F equal to minus du by dx, dx left side take place left side, so du equal to minus f dx. Now take integration both sides, so u is equal to minus integration 0 to x minus kx x cube dx. Zero to x minus kx plus ax cube dx, तो u is equal to, इसका डिफरेंशिएशन k कांस्टेंट x रेज टू 1, तो मीन्स 1 plus 1 2 by 2 minus minus plus kx square by 2 minus a x raised to 4 by 4. This is the potential energy relation with displacement x. So now we get u equal to 0, means take x equal to 0, so 0 0, so u 0, and also x equal to root 2k by a, तो मीन्स सेकंड केस x हमें फाइंड करना है यहाँ पर, तो x equal to 2k by a, put this value in this equation, k by 2 here under root 2k by a, so we write here, तो x equal to 2 under root 2k by a, तो मीन्स स्क्वायर है, तो 2k by a, यहाँ पर x रेज टू 4 by 4 है, तो यहाँ पर रखते हैं, तो हमें u 0 मिलेगा. u क्या मिलता है? 0. ओके, तो वी राइट u 0 एट पॉइंट x इक्वल टू 0 और x इक्वल टू रूट k बाय a, बट u नेगेटिव, तो x ग्रेटर देन रूट k बाय a लेंगे, तो a वैल्यू है मोर देन फर्स्ट टर्म, देन u नेगेटिव मिलती है. तो यहाँ पर वी राइट x इक्वल टू 0, तो u इक्वल टू 0, तो x इक्वल टू 0, तो u इक्वल टू 0, x इक्वल टू रूट k बाय a, तो सब में a b और d तीनों में x इक्वल टू 0, तो इक्वल टू 0, a ग्राफ तो आएगा ही नहीं. तीनों में से क्या है लेना है? सेकंडली x इक्वल टू अंडर रूट 2k बाय, तब भी u 0, यहाँ पर सेकंड टाइम u 0 नहीं, यहाँ पर नहीं है, ये भी नहीं आएगा, ये दोनों में से आएगा, तो यहाँ पर 0 है, यहाँ पर 0 है. ओके, तो दोनों में से अब क्या है? तो u नेगेटिव x ग्रेटर देन अंडर रूट 2k बाय a, तो यहाँ पर x से ज्यादा, 0 से ज्यादा, यहाँ से ज्यादा x लेते हैं तो u नेगेटिव मिलता है, लेकिन हियर u पॉजिटिव है, इसलिए ये भी नहीं आएगा, यहाँ पर u नेगेटिव है, ये आएगा. तो ये हमारे पास ग्राफ है. From the given function we can see the f equal to 0 at x equal to 0 is that slope of u of x graph is 0 at x equal to 0 all में. Next, the potential energy of a body is given by a minus bx square. A minus bx square, potential energy given, where x is displacement, the magnitude of force acting on the particle is. So here f equal to minus du by dx minus d by dx, क्योंकि वैल्यू पुट करते हैं, a constant, differentiation with x is 0, माइनस माइनस प्लस b, x स्क्वायर का डिफरेंशिएशन 2x, तो हमें मिलेगा 2bx, तो 2b कांस्टेंट f प्रोपोर्शनल टू x, तो हमें आंसर मिलता है प्रोपोर्शनल टू x. ओके, नेक्स्ट The potential energy of a system is represented in the first figure. U versus X का graph given. The force acting on the system will be represented. तो इसका स्लोप F इक्वल टू हमें मालूम है -u/dx. इसका स्लोप पॉजिटिव है तो F नेगेटिव मिलेगा, तो ये तो आएगा ही नहीं. F नेगेटिव ये तीनों में है, ये भी नहीं आएगा. ओके, क्योंकि du/dx कांस्टेंट है, F कांस्टेंट मिलेगा, तो ए ग्राफ और ए ग्राफ आएगा. अब यहाँ पर है u वर्सेस x का ग्राफ स्ट्रेट है, तो इसका स्लोप 0 मिलेगा. स्लोप 0 तो मीन्स f 0. तो यहाँ पर ये भी नहीं है, यहाँ पर चेंज होता है, ये भी नहीं आएगा, तो यहाँ पर f 0 मिलता है, तो ग्राफ आएगा ये C. ग्राफ मिलता है C. अब 34. A particle move in the potential region given by, यहाँ पर potential energy given U is equal to 8x square minus 4x plus 400 joule. Its state of equilibrium will be, तो equilibrium कहाँ पर मिलेगा? तो condition for the equilibrium F equal to 0, F equal to minus du/dx. Minus d/dx 8x square minus 4x plus 400. Now we take f equal to 0. 0 we take, so 0 is equal to 8. X square means 2x minus 4 into 1 plus 400 का difference is 0. Therefore 16x equal to 4. Then x equal to 1/4 meter. 1/4 means 0.25 meter in a centimeter, 25 centimeter. The answer is 0.25 meter. Okay, तो ये हमें याद रखना है. अब नेक्स्ट पॉइंट लेना है.